Hello everyone, today we are going to explain the basic concepts of OSPF. Previously we have actually talked about OSPF, and we mentioned that OSPF can be applied not only in our enterprises, but also in our campus networks. For example, in this area we can run OSPF between the core switch and the aggregation switch. This allows the routers in our campus network to communicate with each other. In this context, if you want to understand OSPF in the future, we need to first clarify a few concepts. First, in this context, you need to understand what an area is. Here, this is an area number, arrow 0, which is its area number. All devices need to be in the same area if they want to synchronize. Each device will generate its own information, such as who it is, where it is, and what interfaces it has. Each device will generate its own information, and they will interact with each other, exchanging information, mine to you, yours to me, and his to me, and mine to him. In this context, they will eventually synchronize into a database. For example, on R1, its LSDB, link state database, will record its own information. In addition to this, IME, there is also R2, which has its own LSA, and R3's LSA will also be stored in RE's database. In the same area, all the devices' databases are unified, meaning we will have the LSA information of all devices in the entire area. If that's the case, everyone should be able to imagine it. Suppose I have a lot of devices all in one area, then my database will be very large. At this point, each device not only needs to know its own neighbors, but also who the neighbors' neighbors are. In this way, it consumes resources. For example, if your company has 10 people, normally with 10 people here, we only need to remember what these 10 people are called, what their hobbies are, who they know, and who they get along with. We get to know each other. But if during this process your company is a large enterprise, 1,000 people, can you put all their hobbies, names, friends, and all kinds of information in your mind? Your brain might have too much to remember, and it's very likely that we can't remember everything. For devices, this severely consumes their resources. So what do? Here we can divide into regions. For example, still with these 1,000 people. So here we divide into 20 regions. Right? Each region, 50 people. Each region only needs to record the information of the 50 people within it. In this context, the region numbers must be the same. To establish neighbors. If our region numbers are different, can we establish it? No, we can't. For example, if I say to you, hey, hello, I live in such and such community, and you say, oh, I also live in such and such community. Only then can you both say, oh, it turns out we are neighbors. So here, regarding the region number, what is it based on? It is based on which region the device interface belongs to. For example, if I have this R1 and the 0 interface on it is in region 0, and if I have another interface, say this interface is interface 1, then I can say that interface 1 is in region 1. However, I cannot say that this entire device is within a single region, because in this context, it is divided according to interfaces. For example, hey, my 2 interfaces, or all my interfaces are in area 0, that's fine. But you absolutely cannot say that this router belongs to a certain area, because it is divided according to interfaces. Now, if in this process, if all devices are within one area, then we will interact with each other. In this context, area 0 is generally called the backbone area. Besides this, we also need to understand another concept, Huawei. For example, in this process, we need to understand the router ID, which is an ID for the router. We say that here the router ID is represented in the form of ... which is actually just a format, similar to our IP address. But does it have the significance of an IP address? No. If I call this router ID ... does it mean I must have an interface with 1.1.1.1? This is neither necessary nor present. It just happens to look like an IP address. Moreover, in this process, our router ID must not be duplicated. Why is there such a requirement here? For example, right now in this context, we have this situation. Here is a router, and here is another router. Among these three routers, we connect them together using either network cables or optical fibers. They are router 1, router 2, and router 3. So, now, if we consider R1 here, what is its router ID? Its router ID is 3.3.3.3. R3 also has a router ID of 3.3.3.3. Now, if during this process, R3 has a route like this: 192 o'clock, 168 o'clock, 1 o'clock, 10. Alright, now during this process, R2 and R3 say they have this route and they will inform their neighbors because they want the others to learn it. Now, after informing R will pass it on to its other neighbors, meaning it will synchronize the information with its neighbors. So, who does it send it to? It sends it to R1. But what will R1 receive now? The message it receives is, I am 3.3.3.3, and I have the route is 192.168, 1.10 RE. The message received now is just this one. But then he thinks, I am 3.3.3.3, and I don't have 192.168.110. At this point, he will send another route, telling others that he doesn't have this route. When our R receives it, he will pass this message to others and remove this route from his table. So after he passes it to R3 will think it's strange that I am 3.3.33, and I clearly have 192.168.1.10. In this situation, it will continue to send announcements, telling others that it has the route, while R1 continues to say, I don't have it. In this process, can R find 192.168.1.10? It can't find it, because the message changes constantly, making our network very unstable and one-hit. Therefore, in this context, our router IDs must not conflict. And if two devices are to establish an OSPF neighbor relationship, they must not be duplicated. If they are duplicated, it will not be possible to establish a connection. So during this process, if I don't configure the router ID, will it still exist? Yes, it will generate itself, as we say here. In fact, within our OSPF area, uniquely identifying a router is equivalent to a person's ID card. Here, the router has an ID that we can manually configure, or we can let the system automatically assign and generate it. Now, during this process, let's take a look. If during this process, how can I manually configure it? By using a command called OSPF with the corresponding process. For example, process 1 followed by router ID, and then we configure it. An ID. For example, 1.1.1.1, this is manually configured by us. However, if we do not manually configure it, it will automatically generate a global root ID or a system root ID. So why is there such a concept? It's because not only OSPF has a root ID, but many protocols like BGP also have the concept of a router ID. If you're too lazy to configure it, but my device still needs to be identified, for a device, I might as well assign one to you. And you can just use this generic one. For example, when each of us plays a game, we all need to choose a game name. Often, many games will provide one for you. You can choose randomly or follow its suggestion. To use all, and during this process, you can also set it yourself. If you're too lazy to think of a game name for yourself, that's fine. You can use the one it automatically generates for you. There. This is similar to the concept of our global root ID, Hawaii, meaning if you're too lazy to configure it or you don't want to imagine it, but you still need a name, that's okay. You can use my global root ID. So how is the global root ID chosen? Is it randomly generated? Not at this time. It will choose the first interface that is up on my device, meaning my physical interface is up and you have assigned it an IP address. In this process, I will choose this IP address as my global root ID. In the future, if you don't configure it manually, you will follow this method. If there are multiple interfaces on my device that are up at the same time, then what about the time they are activated? Are almost the same, making it impossible to choose in this situation. When we cannot adjust the time, we will choose the larger IP. For example, if my current interface is 200, 200, 200, 200, this interface is 1.1.1.1, and this interface is 3.3.3.3. So, in this process, which one will I choose? I will choose the above interface, its IP address as our router ID, because if I don't manually configure it here, it will select this global root ID. But here you might ask, if I don't want to use this global root ID, can I just change it at will? Well, this is also not allowed. Okay. After modification, we need to restart the OSPF process. Otherwise, if we modify it, it will take effect immediately. Now, suppose we have these three devices. These three devices are exchanging routes with each other, namely R1R and R3. At this point in the process, one of them sent some data, and the announcer also indicated who generated this data, saying it was 1.1.1.1. The second device had just passed this route along when suddenly it said, "Hey, I've changed my name. Now I'm called 5 Point." At 5:30, now during this process, when R3 looks for this route in the future, who does it find? It finds 1.1.1.1, but can it find 1.1.1.1 in the network? It cannot because R hasn't discovered it, so it will only take effect after a restart. We open ESP, click Yes here, and we choose the router to conduct an experiment for everyone to see. Here we drag one router and then drag a second router and connect them. We connect our 0, 0, 0 to the J0, 0, 0 of the device on the right, and here we need to power it on. By clicking the power button above, it will start all the devices in our topology. So, in the future, we can freely choose the devices we want to use, ASLs. For example, if we need a router during the learning phase, using the A22220 is sufficient. What about other router models? Sometimes issues may arise, because different devices and models may not support certain commands. Here, we wait for it to power on. If in the future you want to know the interface type and interface number of this device you see, you can click the button above, and it will display the numbers of all the interfaces, making it convenient for everyone to conduct experiments in the future. Don't just say, "Oh, I chose this J0 is 0. In the future, when configuring, if you forget your IP address or what the interface is, you can use this to see it. For example, right now between our R1 and R2, if the point in the middle turns green, it means we have successfully powered on. We can double-click to enter and configure it here. Now, in this context, we say, angle brackets indicate our user view. Basically, we can only view certain things. If we want to enter, we need to use the system wave command to access our system view. Now, in this context, if we see square brackets in the future, this indicates our system view. For all Huawei routers or switches, as long as they are in an enterprise setting, their name is Huawei. If we want to rename the devices we configure in the future as they increase in number, we need to enter the system view, followed by the name you want to change it to. For example, if I want it to be called AR1, then you input it afterwards. The name AR1, now in this context, if in the future you want to merge its window, click this button, free. After clicking, you can see here that after we rename it, the name inside the square brackets changes to A21R. Here we also first enter our system view. After entering, change its name to our A22T. Once all changes are made, we then configure its IP address. For example, for R1, we configure its IP address by setting up the interface J000. Enter this interface to configure it. During this process, let's say I assign their IP address subnet as 1.2. 1.1.1.1 is our 1.2.1.1.2 cell. During this process, we need to go inside the device to configure it as 1.2.1.1.1, followed by its subnet mask. This is actually content we've covered in previous lessons. So if anyone doesn't remember, you can review the earlier courses. Here we can choose to input its subnet mask length, or we can enter something like 255.255.255.0. The dotted decimal format, generally in our entire experimental process, the wildcards we use are basically 24-bit. Because in this process, including the fact that we are just conducting experiments now, there's actually no need for us to classify it further. For example, here we are all using 24-bit. After configuring the IP paper like this, we then go to R to configure it. Similarly, we need to enter the interface J000, IP address 12.1.1.2, and then the 24-bit is here. We have configured the IP values on both sides. After finishing the configuration, what's next? At this stage, we must remember that in our network, we are not in a hurry to make other changes. The most important thing is to test whether our IP address is configured correctly. We must not make mistakes in IP address configuration, such as entering the wrong number. But if we enter 2E instead of 1 and we don't check it, it will be very difficult to troubleshoot later. Now, we can ping this 1.2.1.2 to see if during this process I receive a response from the other side, which would prove that my IP is correct and the other side's IP is also correct. Okay, now that we have successfully pinged, if in the future I don't set it up. What will I use by default? By default, I will use my global root ID. How do you check what the device's global root ID is? You use the command display root ID. Now, during this process, we can see that the current root ID is 1.2.1.1, and it will be based on the first interface that comes up on the device. Or choose the interface with the largest IP address among the interfaces, 12 that are up simultaneously. Here, if we create OSPF1, we can create an OSPF process. Then, just press enter, and it will assume by default that you haven't configured the router ID. At this point, you can check the OSPF router ID, for example, by using the command display OSPF peer. Briefly, during this process, let's look at its process. In OSPF, it will assume that you want to use the global root ID 12.1.1.1. In the future, if we want to make changes, at this point, we need to make some modifications using OSPF, followed by router ID 1.1.1.1. During this process, it will also prompt you about this configuration. It has already succeeded, but you need to restart the OSPF process to change to our new router ID. In this case, if you want to restart, you need to enter our user interface by using reset OSPF. Or during this process. You can use the command to reset it, and before it resets our OSPF process, it will ask you to confirm whether you want to proceed. We input yes here, and then we check the router ID again. Using display OSPF peer brief. During this process, we can see that the router ID has changed to 1.1.1.1, but this change is only for future checks. Will there be a change in the ID? No, there won't be. You are only resetting our OSPF, not changing the global settings during this process. For example, we are currently using the initial default settings here. Recognize the game name assigned to us. If you want to have your own unique feature on YouTube, you can change it to a hobby of yours, or create a name for yourself. Have you changed it on other platforms? If you haven't changed it, it will still use the system ID generated globally. In the future, if you want to modify this router ID, we say you can use this command for the global one. During the process of setting the router ID, we need to pay attention here. In the middle, you must add something, and be sure to input the full word router without missing an R. After that, we add the ID. Now, if we type a question mark here, we can see that we can modify its global setting. For example, If we want its global root ID to be 2.2.2.2, after making the change, during this process, we can now check the display here. Router in the ID. We can see that its router ID is 2.2.2.2, which means one is modified, our OSPF process, and the other is modifying our system root ID. This is our root ID, and each device can only have one, and they must not conflict with each other. Besides the concept of the router ID, we also need to understand another concept, which is the calculation of our OSPF cost value, Huang. Here, we can control this cost value. So, what is the calculation format for the cost value? Quote. It is calculated by dividing our bandwidth reference value by the actual bandwidth of our interface. For example, in Huawei, this bandwidth reference value is 100 Mbps. So, if the interface we connect in the future is a gigabit interface, which is 1000 Mbps, then when we calculate the bandwidth of an interface, it would be 100 divided by 1000 equals 0.1. Now, in this process, if the result is less than 1, we take the value as 1. The default cost value for each interface is 1. When I calculate in the future, for example, during this process, when we look at different types of interfaces, their bandwidths are different. What if it's a serial link? The default is 1.544 Mbps. If it's our F port, the default is 1. And if it's this port, the default is also 1. Here, due to the specific bandwidth value, each OSPF interface actually has a specific cost value. Generally speaking, the OSPF cost is the sum of the cost values of all incoming interfaces along the path from the destination network to our local router. For example, if we are now looking at the routing table in R3, it needs to calculate the cost to reach the 1.1.1.024 network segment. It needs to calculate, and first we need to calculate the cost for this network segment. Reaching R1, its cost is calculated. Then the cost from R1 to R is added. And then we add the cost from R2 to R3, which is 64. So here, the total cost is 10 plus 1 plus 64, which equals 75. In this process, this is how it calculates Y, meaning the sum of the incoming direction costs. Now, let's talk about how OSPF handles this. How do we establish neighbors and synchronize our data? Actually, it's achieved through the interaction of 5 types of OSPF messages between our OSPF routers to perform different functions. For example, what are the names of these 5 types of messages? Hello, DD, LSR, LSU, and LSA. The hello message is used to discover, establish, and maintain our OSPF neighbor relationships. For instance, in the future, if you see someone on the street, what do you think? If you feel a connection with him at that moment, you would greet him, "Hey." In this context, he would know that you are greeting him, and he would definitely notice you. After noticing you, you can get to know each other through this way of greeting, establishing a relationship. Once established, if you meet again on the street next time, you will continue to greet each other to maintain this friendship. We all use this hello packet and our DD packet. It describes the summary of the LSDB to synchronize the databases of our 2 devices. For example, in the future, if you want to establish this kind of close friendship or neighbor relationship with someone, you hope to tell them some things you know, and they also hope to tell you some things they know. It's like you have many books in your hand, and they also have many books in their hand. You wouldn't just directly give them the books, because what if there are overlaps between the books you have and the books they have? For instance, if you both have this book, during this process, we can. First, copy the table of contents for the other person to look at. Hey, which ones do you have and which ones don't you have? Then, we can exchange with each other, preventing us from exchanging unnecessary books in this process. For example, I send him the table of contents of my books. After sending it to him, he will check which ones he doesn't have. If he doesn't have them, he will send an LSR request to ask me for them. At this point, once I receive his request, I will send him an LSU, which contains the actual LSA. In other words, if you don't have these LSAs, no problem. I will send them to you by placing the LSA in the LSU. So what happens when the other party receives it? They will definitely tell you, oh, I received it, right? At this point, they will send an LSAC to confirm receipt. In OSPF, the main focus is on 3 processes. First, we need to establish our neighbors, and then calculate using the SPF algorithm. Finally, we calculate our OSPF routing table. In this context, there are 3 routing tables, and these 3 tables are very important. For example, during this process, the first table is our neighbor table. The neighbor table will record what kind of neighbors I have established. For instance, in this context, we can use it in the future. We use display OSPF peer to check who my neighbors are, what my address is, and what their address is. Here, we establish the neighbor relationship through hello packets, and we can use display OSPF peer to check the status information. In addition to this, we also have our LSDB, which is the link state database. It stores the router's own LSAs as well as the LSAs received from neighbors. For example, in this context, our R1 has 3 LSAs. Here, the type describes the type of our LSA, and the advertiser indicates who sent this LSA. We can view this link state database using the command display OSPF LSDB. Apart from this, so how does it work? According to the licenses in our database, I will perform SPF calculations, and after calculating, I will place it into my OSPF routing table. This means that based on the optimal routes learned from OSPF, the OSPF routing table and the routes. What about the routing table for oil and gas? It is different. In this context, our OSPF has 3 routes, for example, in this case. In an OSPF routing table, we can see that it contains, for example, our target IP address, our cost, and our next hop, all of which are included. This information guides the forwarding of our data packets. In this context, if we want to check the optimal route calculated by OSPF in the future, we can use display OSPF routing to view it. Of course, this is just the route calculated by OSPF. In the future, if we want the router to execute and forward, we also need to place these optimal routes calculated by OSPF into our global routing table. If anyone wants to learn Huawei certification technology or obtain Huawei certification question banks, please send me a private message. I can also leave more comments below the video for technical exchanges.